Hey everybody, hey you 13s, glad to see you there. Right, okay guys, and I love the fact I've got 9 viewers already. That's outstanding. You guys are all there waiting for me to go. Thank you very much, guys. Right, I'm gonna get straight on with it. Share my screen. Let's crack on. I am on. There you go. Just gonna pause that really quick. I know I've got 2 screens running simultaneously. You see, so I'm just fiddling around with that so I can, because all I actually need on the other side is my chat window, which is now there, which is great. Edit. Oh, that's okay. Should be there. There's my chat window. How do I pop out chat? Ooh, that's exciting. Can I just pop out the chat window? Nothing else to see. We popped out. That's funny. Now, if I close that, I think I'm going to lose it. So I'll just minimize that. There we go. So my YouTube chat window is up and running, so I can see you guys. Right, let's do that one there. Right, okay guys, I'm also going to disable my camera because I've realized that if I do that, just disable device, because you guys don't need it, but it's running anyway on the computer. There we go. It also makes my laptop run a whole lot smoother. Okay, right, let's crack on, guys. Homework review. So I'm hoping this isn't going to take a particularly long length of time. Let's flatten out and get ready. Right, okay, guys. I've got my calculator to hand. Amazing. Right, so first task, first homework, just add a 12, nice and easy. It says calculate the pH of the following solutions. Okay, so what I'm going to do is I'm just going to try the best I can to fit everything in. So we know that HCl ionizes in a 1-to-1, which is great, which means the concentration of the hydrochloric acid of 0.2 is also the concentration of H+. So all I need to do is minus log 0.2. If you can do to the base 10 if you wish, minus log 0.2, and I get a pH. So answer number 1, answer for A, is a pH of 0.6. Oh, that's interesting. So that's an important one. 2 decimal places. They've done that on purpose. Rounds to 0.70. Like it. Next, I've now got... yeah, that makes total sense, doesn't it? Because a 1 molar solution of HCl is 1. That's nice. So, or 0 even. So, okay, so 0.5 molar. So again, with nitric acid, yeah, we're seeing it ionize. This is the Bronsted-Lowry equation to form. It's a 1-to-1 again, so it's the same 0.05 as the nitric acid. So then I'm just going to go minus log 0.05. So this is more dilute by quite significantly. More dilute than the previous ones, where minus log 0.05. I should have a higher pH, which I do. So pH of 1.70. Great job. Next, C, sulfuric acid sets off alarm bells in our ears. 0.04 sulfuric acid. So this is C. So we know that sulfuric acid is important because it's diprotic. Yeah, so we're going to get twice the number of it, and it was 0.04 for the sulfuric acid. So I'm going to have, it's a 2-to-1, it's a 1-to-2 ratio. Sorry, it's loads better with my camera, not 1. It becomes 0.08 minus log 0.08. So minus log 0.08, and I get an answer and a pH of 1.10. Notice they're all designed for the 2 decimal places as the round up. It's rather clever, that. D, last one, nitric acid, 2 molar. D. Nitric acid, yeah, 2 molar. Holy moly, that's very strong nitric acid. That's rather scary, that. 2 molar, 2 molar. It's a 1-to-1 ratio. So minus log 2, minus log 2, minus log 2. And I get an answer of a negative pH, which is always important that we talk about. Oh, I've got to be careful of that. pH equals minus 0.30. And I'm done. So 4 marks, guys. There's my first 4 marks ticked off. 1, 2, 3, and 4. It's cool. It's nice to do the ionization equations. Nice to see sulfuric acid in the 1-to-2 ratio, and nice to see a negative pH as well. How nice is that? Lovely set of questions, hitting all the boxes. Okay, calculate the concentration of the following acids. They've asked us to reverse it. So A, in this case, I'm going to shrink my pen down. I may as well at this point. Yeah, so A, I need 10 to the minus 3.55. So shift log minus 3.55. If anybody wants me to explain that, I'm quite happy to do so. So the definition, this is where my laptop is, finding things a little bit tricky. So just to explain that pH equals the negative log to the base 10 of H plus concentration. If you reorganize this, the first thing that we need to do, we want to reorganize this so that we can get the H plus out of the pH. So if we first of all, what we're going to do is we're going to do, therefore, we're going to flip the sign, and we get negative pH equals log to the base 10 of the H plus. The next thing is we need to anti-log everybody. So we can go therefore. So we can go, because if I now anti-log everything, what's going to happen is if I anti-log everything, that becomes 10 to the power of the negative pH, and the log now disappears, because if you do 10 to the power, if you do, 10 to the, multiply that by 10 to the power, 10 to the x, which is the equivalent log of it, then what's going to happen is that cancels with that, but then you have to multiply the other side by it as well, which is 10 to the negative pH, gives us the H plus concentration. It's just nice to follow that reorganization through. So I now have a pH of 3.55, so I go shift anti-log minus 3.55, so anti-log minus 3.55, and I get a H plus concentration of 2.82 times 10 to the minus 4, and that's H plus concentration. And the great thing is, because HCl is monoprotic, it's the same answer at the end. So there's my final answer for the first one. I like it. It's the concentration, calculate the concentration, and that is the concentration. It's tiny, absolutely tiny. Well, to get hydrochloric acid at a pH of 3.55, God, you have to be very dilute. 1B is wrong. Oh, what? Have I made a mistake? What have I done? Have I made a mistake? Minus log 0.05. Oh, I've made a mistake. I've typed it in wrong. Sorry. Thank you, Ivan. Yeah, I think B is wrong. B is wrong. You're absolutely right. Guys, I've typed it in wrong. How interesting is that? Yeah, so that should have been 0.30. I wonder what I typed in at the end there. Thanks, guys, for pointing that. I got 1.3. Yeah, it's correct. I'm sorry, guys. Yeah, I must have typed it in wrong on my calculator error. Next, now that I've done the reorganization of that, I don't really need to do it again, but sulfuric acid is a screamer. We know that this one's going to be one of a problem because it's diprotic. So what we're going to do, so this is B. So we now do 10 to the power of minus 1.7. Minus 1.7, so shift antilogs minus 1.7. And I get a concentration of 0.0200. Isn't that interesting? There you go. And that's a concentration of moles per dm cubed of H plus concentration. Now we know if we look at the equation for sulfuric acid, if we go from in that direction, we realize that we've got a H plus and we need to go back. It's a 2-to-1 ratio. So I need to divide that by 2. My final answer is 0.01 moles per dm cubed. I'm just going to get rid of all this working out stuff. Don't need it anymore now that I've done it. Of sulfuric acid. So there's my final answer. Finished. I like it. Next, I like it. Let's get rid of all this stuff. This is where I kind of want to just move everything so I can fit everybody on. 0.01, and the other one was 2.82. 2.82 times 10 to the minus 4. There we go. Cool, so I can get rid of all this stuff now. Right, next, question number 3, nitric acid, pH. So for C, we've got 10 to the minus 1.3, so shift log minus 1.3. I get a concentration of 0.050, so that we're done. So it's actually just 0.05 because it's 2 decimal places. I've suddenly realized, okay, that's actually okay. And then, so it's a 1-to-1 ratio, so that's the right answer. I'm done. Cool. Next, sulfuric acid, I've got a negative in there. So 10 to the power of minus, brackets minus 0.5. That's a deliberate thing, guys. That happens a lot in exams. They love that. Everyone forgets it. Shift log minus, brackets, minus 0.5, close brackets. Right. So I have a concentration of H plus as 3.16 moles per dm cubed. Okay, next, now it's sulfuric acid. So H2SO4 going to 2H pluses plus SO4 2 minus. We're going in that direction. It's a 2 to 1. I'm going to divide that number by 2. So on the calculator, the final answer is going to be 1.558. And I'm done. Moles per dm cubed. I love it. Cool. Nice. 4 marks. Tick, 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 tick. Thank you very much. Right. Last section of strong acids. Right, this was a bit more tricky because essentially they've given you it in grams per dm cubed. You've got to do a conversion to moles per dm cubed before you can run the pH. Okay, so first step that we've got to do, in order to go from grams per dm cubed to moles per dm cubed, what you realize is the dm cubed is not changing. We're just going from grams to moles. So number of moles is grams over rams, but we're going from grams to moles. So we need to reorganize. So if I reorganize that, rams times moles gives me grams, but then actually what I want is I want moles. So I'm just going to reorganize that and bring the n down. Oh, hang on a minute. I want moles. Grams over rams. What am I doing? I'm running around in circles when I don't need to. It's grams over rams. That's easy. Number of moles is grams over rams. I'm going from grams to moles. That's all I need to do. Right. So number of moles equals grams. I've got 10 grams per liter over the relative atomic mass of HCl, which is 36.5. Can I just please, year 13s, wait, guys, is 2 decimal place only for pH because he did 2dP with conc as well? All right. It should be 3 sig fig with the concentration as well. You're absolutely right. No, Ben, I'm wrong. Thank you very much. Well, I can't be bothered backtracking now. It's at least half my answers. So you get the point. Yeah, it should be 3 sig fig. Ignore me, Ben. Thank you. I think it's 2. No, it should be 3 sig fig. Ria, always. Only pH differs. So it's, can I just please emphasize, yeah, you guys often do 1 plus 35.5. Can you stop doing that? Yeah, that's not allowed. You must give the total answer, 36.5. 10 divided by 36.5 gives me 0.274 moles per dm cubed. Right, now I've got the concentration in moles per dm cubed of the HCl. We know that that's also the concentration of H+, so we can just minus log answer, and I get a pH to 2 decimal places, pH 0.56, and I'm done. Next, okay, same process again, but this time for sulfuric acid. Cool. So for sulfuric acid, I've got number of moles is grams, 20 grams over sulfuric acid. What does sulfuric acid weigh? 1 times 2 plus 32.1 for sulfur plus 16.0 times by 4. Add that all together, I believe, is 98.1. So 2 plus 32.1 plus 16 times 4 gives me 98.1. And if you don't do that number, you're going to lose 1 mark and it'll add up really quickly. Please don't do it. 20 divided by answer gives me a concentration of 0.204 moles per dm cubed of sulfuric acid. However, sulfuric acid is in a 2-to-1 ratio, so I'm going to double it to get the concentration of H+, which gives me a concentration of H+ of 0.408, and then I'm going to minus log my answer, and I get a pH of 0.39, and I'm done. Take it if you got it. Next, see, I shouldn't really be deleting this, but I didn't give you any space. It was a nightmare. 50 grams per liter of nitric acid. Okay, number of moles is grams over rams. What does nitric acid weigh? 1 plus 14 plus 16 times 3. I have no idea what nitric acid weighs, actually. It's not something I'm after. 63. So, by the way, I'm about to lose a mark. So it's 63.0. Yeah, so 50 divided by 63.0. Oh, no. 50 divided by 63 gives me 0.794 moles per dm cubed of nitric acid, minus log answer because it's a 1-to-1, and I get a pH of 0.10, and I'm done. Right, 100 grams of sulfuric acid. Now, I've already done the hard work for this. So number of moles is grams over rams, 98.1. So that 100 divided by 98.1 gives me 1.02 times, oh no, that's it, 1.02 moles per dm cubed of the sulfuric acid. But we know that sulfuric acid is in a 2-to-1 ratio to H+, so I'm going to double that times by 2. Then I get 2.04, and then I'm going to minus log answer on my calculator, and I get a final pH of minus 0.31, and I'm done. Right, guys, it's out of 12. I hope you found it handy. Yeah, add in your scores out of 12 on the sheet. That'd be great. Okay, next. Right, on to KW and dilutions. These are a lot more tricky. Now, these are real exam kind of style questions. Actually, no, not some. Yeah, a bit more than the previous one. Okay, so it'd be nice just for me to check to see how you guys are getting on with filling in the sheet. We have a look. Hey, look at the data going in. That's fantastic. Nice to see. Wow, Dana got 111. That's amazing, Dana. That's outstanding. Good job. What? Dana got what? Oh my goodness me. Okay, she's been 11. Woo! Blimey. That was close. Okay, next. Right, write the expression for KW. So KW equals H plus times by OH minus. We're done. Next, what are the units for KW? Oh, that's quite nice, because moles per dm cubed times moles per dm cubed. So that's moles to the 2 dm to the minus 6. Just combine them. 1 mark, 2 marks. Next. Okay, at a temperature, a tiny fraction of a degree less than 25 degrees Celsius, the value of KW is 1 times 10 to the minus 14. In the units, you'll have to quote in your last answer. Use the information to show why the pH of pure water is 7 at this temperature. Right, okay, so first thing we need to work out, so what we do is we say that the I'm going to try and make my pen a bit thicker here and change my color to red. Why not? Make my pen a bit thicker. Okay, to show that the pH of pure water is 7. So, okay, so we've got KW is equal to 1 times 10 to the minus 14. Right, we know that KW is equal to H plus multiplied by OH minus. We did that in the previous question. But now we can get the false expression. Therefore, KW is H plus squared. Now, this is because the concentration of these two is always the same in water. Yeah, because when it dissociates in a 1-to-1. Yeah, it dissociates to give 1 H plus and 1 OH minus. These guys will always have the same concentration. So we can write the false expression. So there's now 1 mark for that false expression being in your working. Next, right, what we can now do is say that we can now rearrange this and go root KW will give me H plus concentration. Right, so if we now run that through and go root 1 times 10 to the minus 14, I will get, so root 1 exponential minus 14, and I get 1 exponential 1 times 10 to the minus 7. So there is 1 mark now for that number, and that equals the concentration of H plus. And now what we need to do is to write down minus log answer, and you get a pH of 7, which is the 3rd mark. Yeah. It's cool, that. Really nice. 3-mark question, highlighting, so you need the false one, the rearrangement with my numbers, and the minus log gives the pH of 7. I like it. Nice question, that. Really enjoyed it. Okay, next one. At 30 degrees Celsius, KW becomes this. Calculate the pH of pure water at this temperature. Is the water now acidic, alkaline, or still neutral? Explain your answer. Well, the answer is it's still neutral. Water is always neutral. So let's see if I can try and squeeze this in somewhere. Right, okay, so they want me to give the pH of pure water. So we can go KW equals H plus multiplied by OH minus. Therefore, KW equals H plus squared. And then, so root KW will give me H plus concentration. And then minus log answer gives me the answer. Right, so we can go root, what's the KW they gave me? 1.471. Oh, root 1.471 exponential minus 14. And I get a number of, so this is the first mark in this regard. Yeah. So the first mark, which I'll do in green, yeah, is that equals 1.21 times 10 to the minus 7, and then minus log answer, and I get a pH of 6.92. And there's my final answer. So 2 marks, 1 for the rearrangement, any one of these rearrangements. That's the one that they really want here. Yeah, then 1 for the answer and 1 for that number there as well. You then need to say, is it, so the answer is, of course, then it is neutral. Water is always neutral. And you can say because the concentration, because H plus concentration equals that of OH minus concentration. We're done. 5 marks. So we've had 1 for that one, 1 for that one. Then we had 3 for this one, 3 for that one, then 5 for that one. Ouch. Next, as the temperature increases, the value of Kw increases. Use your knowledge of Le Chatelier's principle to work out whether the ionization of water is exothermic or endothermic. Okay, so we know that Kw is linked to products. Yeah, so Kc of water is the H plus and OH minus over H2O. This is Kc for water. Yeah, so what we realize is for Kw to increase, Kw increases means increase in H plus and OH minus concentration. So Kw increases, increasing H plus concentration. So, okay, so 1 for writing down, you could have just used Kw if you'd wanted, 1 for that guy. 1 for saying that an increased temperature increases those two. The next one is for saying raising temperature, raising temp, the equilibrium will lower temp by favoring, we're running a whole coughs there, favoring endo, therefore dissociation is endo, which makes sense. Bendo, breaking bonds, is endothermic. Yeah, that's really tricky, that. What I'm going to do is, everyone's going to be like, how many marks is that worth? Well, in reality, it says you're using Le Chatelier. That was asking for a full coughs on this. So raising temperature, yeah, the equilibrium will lower the temperature by favoring the endo, therefore dissociation is endo. See, knowledge, we should have said, well, that's what we were actually working to find out, weren't we? And then the previous one, that's there. So it's actually really interesting looking at how that fits into coughs. What I've actually just done is run coughs in its entirety. We were looking for the knowledge. We gave the oppose mark. It's really interesting. The oppose mark is that one. Yeah, if raising the temperature, equilibrium will lower. Then we ran favoring, yeah, the endothermic process. And then we said the shift is over here. So the shift, which is shift, see, increase in H plus and OH minus, there's that mark. And then the answer, of course, is that it's endothermic. So really, really interesting that. It's very clever. So it's 5 marks technically. Yeah, because the final answer, hang on, is that right? 1, 2, 3, no, it's 4 marks out of 4. You can decide what you get on that, guys. Yeah, depending on how well you've answered it. Just have a think about it. I'm not going to be overly strict here. You can decide how much you're doing. Next, define pKw. Okay, so 2a minus log of the kW, 1 mark. Next, what is the value of pKw at 30 degrees? Oh, they gave me that. There's kW. So B is going to be, I'm on my calculator, minus log 1.471 exponential minus 14. So my B answer, my KW, my pKw is 13.8. Isn't that interesting? Yeah, use the KW value from 1D. Wow, okay, so it's already done it. Amazing. How easy is that? 2 marks. Boom, boom, boom. 2. Next, right, we're on to dilutions now, folks. Now, the first one, I'm so sorry. The first one was really tough. Yeah, it was actually a challenge question. So it says, okay, I'm pretty interesting to see I've got enough space for each of these. Yeah, 46.2 moles of 0.58 and 568 molar nitric acid solution is mixed with of calcium nitrate solution. Okay, so they've mixed 2 solutions together. What is the nitrate ion concentration at the end? That's really clever. Right, so what we need to do is we need to work out the total moles, yeah, of nitrate ions, and there's 2 per molecule. Number of moles is C times V over 1,000, because I'm in milliliters, that's centimeters cubed. Shouldn't have used that question. Mr. Duncan, for 2A, just curious, could you say minus log? Good question. Sure. Don't see why not. Yeah, can. Don't see, it's the same thing. Yeah, Ben, you can have it. Or can you say minus 2 log H pluses? What? No, you can't say that, really. That's garbage. Or is that really wrong because it's false? Yeah, you can't do that. Ben's okay, but yours isn't real. Good question. Right, so I'm going to work out the moles for this guy first. This guy's going to go in green. So C, concentration 0.568, multiplied by 46.2 all over 1,000. So I get the moles of calcium nitrate in the first one to be 0.0262 moles. Now, here's the clever bit. When you put calcium nitrate into water, look at what happens in terms of the ionization. Ca2 plus 2 nitrate ions. Right, so in terms of nitrate ions, I need to double it, times by 2 to get me nitrate ions. So times by 2, and I'm going to get 0.0525 moles of nitric acid, and I'm going to underline that. Okay, not the easiest thing to see. Next, I'm going to do the next bit in let's do this in, no, I'm going to, change this to red. So let's do this one now, yeah? So this one is number of moles equals C, 1.396, multiplied by V, 80.5, all over 1,000. So 1.396 multiplied by 80.5 divided by 1,000 gives me 0.1124. 112, we can just do 2. Right, and that's moles of calcium nitrate again, so I need to double it again to get more nitrate ions. Yeah, so I'm going to have 0.0225. Right, now what I'm going to do, 225, what I'm now going to do is add those nitrate ions together. So this is the this is the moles of NO3 minus here, and the moles of NO3 minus there. We'll just combine them together. So I'm going to add that to 0.0525. I'm going to get a rounding error, but it's okay. And I get, so total is 0.277 moles. So that's the total moles of nitrate ions. Kind of makes sense. Is that right? Doesn't look like it. Oh, yeah, because I've written that down wrong. There you go. Yeah, looks about right. Okay, now that's my moles. I just now need to give it into concentration. What's the total volume? Right, total vol is equal to 46.2 plus 80.5. This is a lot of work, guys. 126.7 centimeters cubed. Right, reorganize. Got number of moles equals C times V over 1,000. I'm looking for C. Bring the 1,000 up. So times by 1,000. Let's get rid of that. And then get rid of we now need volume over that side. And then I got concentration. So I run my moles through. 0.277 times 1,000 divided by a new total volume of 126.7. So I get a final answer of 2.19 moles per dm cubed. But you end up, if you got it, an alternative is to use ratios. In the exam, you can give concentration in terms of M, or will it only be, you're never allowed to give M. I've told you this, Nikita, you are not allowed to use it. You are banned. Yeah, DAT, concentration equals 2, yada, 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 yada. Ew, from Maria, I did it in one line. Good for you, DAT, good for you. You're going to get only 1 mark. Yeah, it's fine. So, guys, I need to talk to you about DAT's answer here. That question there would be a stretch. It's grade A at A level, that is. The reason being is that's a 4-mark question now. It's 4 markers. DAT gets 1. Yeah, the reason being is the whole point of the exercise is, can you work out the moles of each one? Do you understand that the total volume is going to change? And therefore, can you reorganize it in order to get a final answer? So that's out of 4. Dat, I need you to be really careful about this. I understand you're good at maths. You know, the best student I ever taught in chemistry did not get the A star because he does stuff like that. Yeah, I'm just warning you, that you can look at mark schemes all day long and you can decide what you want to do. I'm just telling you it's a bad idea. Just letting you know. Okay. Next, this one, okay, they become a lot easier now at this point, guys. So if you dilute, so number of moles, oh, hang on a minute, this is a straightforward dilution. C1V1 equals C2V2. So if you dilute 175 centimeters cubed of 1.6 moles per dm cubed, yeah, 1.6, 175, and I'm going to get concentration. So it says 1 liter, determine the new concentration. The new volume is now going to be 1 liter. Let's reorganize. C1V1 over V2 gives me C2. So I've got initial concentration 1.6 multiplied by 175 all over a new V2, and they are a solution of, if you diluted it to 1 liter, so over 1, will give me 1.6 times 175 all divided by 1 gives me 280. Right, hang on a minute. What have I done wrong here? Done something wrong. Yes, I need to get it if you diluted it. Oh, hang on a sec. Determine the new concentration. I've stuffed that up, haven't I? Determine the new concentration. V1 equals C2. 1.6 times by 175. What have I done here? If you dilute 175 mils V1 of 1.6 mole solution of lithium chloride to 1 liter. I'm so sorry, guys. You've got to divide it by 1,000 because that's in centimeters cubed. It's a trap. Oh, damn. I knew that was weird. That was 1.6 multiplied by 175 divided by 1,000. Wouldn't you have to convert the L to milliliters? Yes, you would. Yes, you would. So the final answer is 0.28 moles per dm cubed. There's my final answer. So 1 mark for the equation, C1V1 equals C2V2. 1 mark for inserting all your numbers and the conversion in the reality. Yeah, and 1 mark for the answer. 3 marks for him. 3 marks. Next question. You need to make 10 liters of 1.2 mole of potassium nitrate. What molarity would the potassium nitrate solution need to be if you were only to use 2.5 liters? C1V1 equals C2V2. Right, reorganize. They're looking for what's the molarity, what's the concentration. So what we're going to do is, and that's interesting because hang on, you want to make, that means it's C1. That's really clever. Really, really clever. Yeah, you've got to rearrange this. So C1 is equal to C2 and V2 over V1. Input my numbers. You need to make 10 liters. So you need to make 10 liters, which is, the liters are the same. The original concentration is 1.2. You're going to start off with the original volume of, is that right? You need to make 10 liters of 1.2, yeah, over if you only use 2.5 liters. So 1.2 times by 10 divided by 2.5. So you're going to need an original concentration of 4.8 moles per dm cubed. Yeah, it's trying to figure out. It's really clever, that, because the equation, the rearrangement, that the original one now isn't worth a mark. There's 1 mark for that rearrangement. Technically, I think it's the same for the other question as well, actually, I think, guys. That's why the rearrangement's always worth the mark and the original isn't. Yeah, there's 1 mark for the rearrangement, not the original. Right, now we need to say C2. It's just the identification. You need to make that C2. Yeah, C2 is there. And then this is, sorry, that's V2. Sorry, that's V2. That's C2. And then from the original, that's V1. And that's really clever, that. It's just trying to identify things and then throw them in the equation. Next, how many milliliters of 5 molar copper sulfate will need to be added to 106 to achieve this? Okay, so C1V1 equals C2V2. Right, how many milliliters of? So they're looking for V1. So rearrange it. C2 times by V2 over C1. Every one of them is doing a different rearrangement. Have you seen that? That's genius, man. I'm loving it. So, okay, that's going to give me V1. Yeah? Right, input my numbers. So how many milliliters of 5 molar? That's C1. Yeah, so that's 5 moles per dm cubed. Goes down there. Then they're trying to achieve C2 of 0.3, and they want 150 centimeters cubed of it. Yeah, it makes sense. So 0.3 times by 160 divided by 5. And I need 9.6 centimeters cubed is what I need. Wow, that's cool, that. 9.6 and 160. That's cool. Next. Okay, last 2 questions are tough. Same kind of thing with multiple equations, multiple solutions. A 40 milliliter solution of 1.8 iron 3 nitrate is mixed with iron 3 nitrate. Count the molar concentration of the final solution. I'm really wanting to show that little thing there, because what's happening here is that if we say the moles, if this is, let's color code this. This one there, that's Sol 1. Let's color code this as best I can. That's Sol 1. Yeah. Sol 2 is this one over here. That's Sol 2. Let's change my color. That's Sol 2. Sol 2. And then we end up with the final one of Sol 3. Yeah. Now what's going to happen is the moles of each one of these is going to combine. So what we can say is that the C times V over 1,000 of solution 1 combined with C times V over 1,000 of solute 2 gives me moles in solution 3. So we can run all those equations. We can do some clever things here. So if I multiply, oh, I'm not very good at this. Oh no. Over 2,000 divided by, I'm not very good at my fractions. I don't know my fractions well enough. That's funny. Ah, damn it. Yeah, I don't even want to get involved with that. I really don't. I feel like I could do that. I could solve it mathematically, but I don't really want to. I just don't really want to. Anyway, solution number 1. Yeah, I'm sorry, guys. I'm going to give up on that front. Solution concentration for the original is 1.8. The volume of that solution is 40, all over 1,000. So 1.8 multiplied by 40, all over 1,000, gives me, and the bottom of this guy is 0.072 moles. Right, next one, solution 2, 21.5 multiplied by 0.808. That one over here gives me, holy moly, that's massive. Oh, divided by 1,000, I'm an idiot. Gives me 0.0174. Right, add them together to give them solution 3. 0.072 plus 0.0174. The total moles is 0.0894. Right, and it says now what's the concentration? The total volume is there. So the total vol is 61.5. So number of moles equals C times V over 1,000. But this time it's asking me for concentration, so times 1,000 to both sides over the volume. Yeah, There we go, gives me the new concentration. So my answer is 0.0894 multiplied by 1,000 divided by the new total volume of 61.5 gives me a concentration of 1.45 moles per dm cubed. Right, interesting. Which kind of makes sense, really, because the first one was really concentrated. The latter one was a bit more dilute, so it's going to be somewhere in between. That's really clever, that. I like it. Oh, yeah, there's Dat doing his clever stuff. So C3 equals C1 plus C1V1 plus C2V2 all over V3. Yeah, you can do that one. Yeah, fair enough. Yeah. Oh, it's okay, I don't care. Next, question number 6. 2 liters, 2 liters of was added to unknown solution. The resulting solution is assuming the volumes are additive. Calculate the molarity of the second. Okay. Right. So this one I'm working backwards on. So number 1 is I've got a total. I can work out total vol. Yeah. So total vol is 2 liters plus 3.88, which is going to be 5.88 dm cubed. Okay. So at least I have a total vol. Yet the resulting solution is there. Right. So the final conc is 0.974. Right, so what I can do is number of moles equals C times V. Now notice I've switched to C times V. I don't need the 1,000 because my volume's in dm cubed. So my total number of moles equals 0.974 multiplied by 5.88. So 0.974 multiplied by 5.88. Gives me a total number of moles of 5.7 times 5.73. Yeah, 73 moles. There you go. And that is technically C1 of it is N1, so it's pretty much found the moles. Yeah, okay. So that's the total moles in the HCl. Yeah. Now what we've got to figure out is we can work out the moles independently for this guy. So the moles in number 1, I'll color code this. Yeah, so moles in number 1, so Sol 1, the moles equals C 0.445 multiplied by 2 liters, C times V, because it's in dm cubed. So 0.445 times by 2. That's cool. That gives me a number of moles for my original solution is 0.89 moles. Right, so solution 2, yeah, and that's clever, isn't it? Solution 2, you add 3.88 liters of an unknown concentration. Right, so Sol 2, we can figure this out now. Yeah, so solution 2, it contains the number of moles is the total moles minus the first solution moles. So total moles equals total moles minus Sol 1 moles. Let's run it through. So the total moles is 5.73 minus 0.89. So 5.73 minus 0.89 is going to give me 4.84 moles in the second solution. And I've also got its volume. So number of moles equals C times V, but I'm after concentration. Divide both sides by V, and I get that. So moles 4.84 divided by the volume of 3.88 liters. Get rid of that. So 4.84 divided by 3.88. Then I get a concentration equals 1.25 moles per dm cubed. Nailed it. Did everyone get it? Mr. Duncan, look at question. Damn it! Look at question 4 again. What have I done? Oh, what have I done? Question number 4. How many milliliters of 5 molar copper sulfate must be added to 160? Oh, no. Oh, no. Yeah, so hang on a minute. How many milliliters of, so there's, that there is C2. No, it's not. I mean, that's C1. Yeah, and C1 is rearranged, yeah, which is there. Must be added to 160 centimeters cubed of water. So, must be added to 160 centimeters cubed of water. Oh, that's okay. I think I may have made a mistake. Plus V1 equals V2. Yeah, I made a mistake in question 4. Oh! Suddenly realized that's a clever question now. Darn it. I'm going to run that. I hate it when I make mistakes, especially when I'm doing it live on YouTube. Very upsetting. So let's have a go at question number 4 again. Yeah, so it says, how many milliliters of 5-molar must be added to 100 to make a solution of 0.3? Right, so hang on a minute. To make, how many milliliters of 5 mole per dm cube copper sulfate solution must be added to 160 milliliters of water to achieve a 0.3? Right, so we've got C1 and we have C2 for sure. Yeah, we're starting with 5. Yeah, we're ending with 0.3. Right. And what we don't know is we don't know the total volume, or we don't know the new volume or the original volume, do we? It's just the ratio of the two. That's horrible. I don't like this. Because it says how many milliliters of the original, that one, needs to be added to 160 to form that. So we don't know the total new volume either. What's the ratio of, let's just reorganize that. C1, divide both sides. C1 over C2 equals C2 over, V2 over V1. Is that the correct rearrangement? Oh, nuts. So hang on a minute. I just want to put the two things on the same side. So I want to divide both sides by C2, gives me C2. Yeah, get rid of that one. And then I want to move over, and that's now over there at 0.3. I want to move the V2, so divide both sides by V1 gives me V1. Okay. So now I can work out, that's really clever, that, isn't it? So then we've got 5 over 0.3, which 5 over 0.3 gives me 16. So in order to get that ratio, I can do, oh, nuts. I'm not very good at this. 16.66. Yeah, and you solve for V1. The ratio of those two is 16.66. So hang on a minute. So the ratio, the second V2 is larger than V1 by 16.66 times. So and that's almost the original number of the 160. Is it 16.66? Is it, what's 160 divided by 16? Put on the answer. 9.6. The answer's not. I just got 9.6. I got my bloody other answer again. Nightmare. But hang on a minute. We can't do that because it doesn't work, does it? Or does it? Hang on a sec. So C1 V1 equals C2 V2. I've got my original concentration is 5 times by my original volume of 9.6 divided by the new concentration of 0.3 gives me, so 5 multiplied by 9.6 divided by 0.3 gives me 160. Now that's the problem, because that's the total, which means I'm not adding it into the correct volume. I'm definitely not correct there. And no, I'm not. How do I solve this, guys? Five V1. Oh. 5 times V2 equals 160 plus, you sub in. V2 equals 160 plus V1. 160 plus V1. Oh, nightmare. Right. And then you can, and doesn't that mean that All over V. But yeah, but then they cancel out. How does that work? 160 plus a V. Oh no, I'm lost. Yeah, and I hate that when that happens to me. Oh, I hate it. C1 V1 equals C. I'm stuck on this now, guys. Have I done the other one? Did I do the last one? Yeah, I did the last one. I'm just stuck on this now. Equals C2 V2. Right, now we know that that is 5. We know that that is 0.3. We don't know what V1 is, but we know that V2 is V1 160 plus V1. Right, so you need to get the V1s on the same side. Yeah, how the heck do you do that? I hate the whole brackets thing. So hang on a sec. Divide both sides by V1. Yeah, but if I divide both sides by V1, yeah, it vanishes from that side. So 5 equals 0.3 multiplied by 160. So what's 0. Times brackets 160 times by V1, yeah, all over V1. So if I do this, so 0.3 multiplied by 160 is 448. So that becomes 48, and then 0.3, and then plus 0.3 V1. Have I gone mad? Yeah, all over V1 itself. Yeah. Oh, nuts. I'm so lost on this, guys. I think what smart people are saying is that V2 is really just, yeah, I know, I'm getting lost in the maths, aren't I? I've kind of got myself all muddled up. I want to put V1 back over to the other side. Minus 48 from either side. So 2 equals 0.3 V over V. What? Oh, which is the same as 2V. V times 2 equals V times... Divide by 2 equals V squared. And then divide that by... That equals 0. What the hell? Why am I stuffing this up, guys? 0.3 divided by 2. 0.15. What am I doing? I'm lost on that one. It's beaten me. Oh man, it's just broken me. It's boggled me. I'm giving up. I'm ending it. I'm giving up. My brain's not functioning well enough. I'm gonna go back. I'm getting rid of this. It's upset me. It has really upset me. It's annoying as hell. Right. Guys, it's annoyed me. I like expand the brackets. It's annoyed me. Oh, I terminated my camera, didn't I? Oh. Enable device. Start cam. Well, ruined that. Stop cam. I ruined it, guys. Everything's all a bit blech. Right. I'm gonna even my camera's backwards.